So for this drawing, I'm going to go ahead and show you how to insert the cap screw from the content center that is embedded in your Inventor. So under your assemble, when we were using to bring in each one of these parts, we were using place. The place from content center is a directory to a list of materials or actually 3D files of things that have already been generated. So these are common fasteners, washers, nuts, bolts, any kind of sheet metal, structural shapes, things that you can upload into an assembly drawing and use and save you a little bit of time and not having to draw it. So the book gives you an option of drawing the cap screw. I'm going to show you how to insert the cap screw using this process right here. So I'm going to go ahead and click on fasteners and click on bolts. There's tons of different types of bolts that are available here. If you go in and look at them, you've got machine screws, you've got sheet metal screws, self-tapping screws, hex heads, cap screws, round heads, slotted, all kinds of different things. So you could spend hours sitting here looking through each one of these pictures trying to find the one that you're looking for. Typically when you're in engineering, you get familiar with what you want, and then you kind of like learn the names of them, and it's easier to locate these items. So I know that I'm going to be looking for the Philister cap screw. So I'm going to go ahead and type that in my search bar, and it's going to go ahead and pop up with that slotted Philister cap screw. So I'm going to click on that, and I'm going to go ahead and be ready to insert this into my drawing. Now, there's a couple ways of doing this. Because this one is going into a counterbore, when I click on this outside circle, it is going to recognize that outside circle as a 7/16, and that is not the right size. I need a 3/8. If I click on the inside circle down there, it recognizes it as a 3/8, but it's going to place that cap screw on that edge, and that's too far down into my part. So because of that, I'm going to have to place my two cap screws on the outside of this drawing and not use the automatic place on this feature. So I'm going to have to specify the size of this. Let me go back and do that again. I should have been prompted for, no, let's go back. So place from content center, I think because I clicked on so many of those items, it was locked in. So I'm going to Philister, Philister cap screw. So this time when I click on it, I'm not gonna point to the inside of my drawing. So this is the box that you should pop up. Because I previously pointed to each one of those, it kind of messed up the selection process. So I'm looking for the 3/8. I'm looking for a nominal length on the length of the threaded part to be 3/4 of an inch. And the thread type was specified on the base plate as a UNF, so that's a fine thread. So when we click on the actual type of thread, that determines or has already predetermined through a set of thread notations that this is going to be a 3/8 24 thread. So I'm going to hit OK, and I'm going to locate both of those cap screws. I'm just click, and then I'm going to right click and hit OK, and that drops those two cap screws over on the right. This is the one I had at the beginning, and it wasn't the right size, so I'm going to delete it. So from here, I'm going to now line this up. If you chose to not do this step and you want to use the one that you drew, you can do the same steps as that I'm doing right now in order to get that screw to line up inside of that hole. So the first thing, well, you can start off with, some people like to rotate this and get this in. For this one, you can move it around. You can kind of get it close to your part, and we're going to constrain, and we're going to start with constraining the center of the bolt to the center of the circle. So I'm looking to make sure that I've got the center. I'm highlighting the center lines, and it's going to plot that over and line up the centers. Once I have that constraint, I'm going to hit apply, and then my next constraint is going to be surface to surface. So I want the bottom of that counter bore, I want that to constrain to the underside of that counter bore. I mean that screw, cap screw. So I'm going to zoom in, rotating it back just a little bit so I can see the underside of it. If you can't see the underside of it, know that you can always move it up, because the only thing you have constrained at this point is the center to center. So if you need to move that part up and rotate it around and rotate it back so you can clearly see it, you still have those options while you're constraining. So I'm just going to pull that back, and woo, it kind of flew away. Let me zoom out. There we go. So I'll just do it again. So constrain, pick this surface here. That was one of my selections. The second selection, I'm going to zoom out, rotate it around a little bit, and now I'm going to pick this inside of that counter bore, and that's going to line that up. Hit apply, and I'm done. All right, so now we're going to take this bolt right here, and we're going to line it up here. So the first thing I'm going to do is line up the center and line up this center, and it turned it upside down. So before moving on, I'm going to want to undo this because I foresee some issues coming up with getting that part to rotate around. So using the free rotate, I'm just going to take this and kind of move it and get it in somewhat of an orientation that I want it to be in when I'm done. So now I'm going to constrain the center of the bolt to the center of that hole, and that lines that up. Now I did drop the piece down just a little too far, so I'm going to pull that out. So I'm just using my left mouse button, and I'm just dragging that and moving it out. So I can do that until I constrain it to the surface. So as long as it's not constrained to the surface, I can move it along any point on that center line. But as soon as I constrain surface to surface, okay, so this is just two constraints on this part, that's going to give me that location. So now that is fully constrained, it's in place, it won't move, I can pick and drag on it. So looking over here on the side, as we look at our parts and you're learning how to use constraints, these bolt or cap screws have been dropped in here. We have constraints. If you over constrain and get these notes where you're saying that you can't move something because it's over constrained, you're going to need to expand out your model on your model browser and look at the number of constraints you have. As you point to the object and you look at the constraints, you can see that there's the center line constraint, there's the surface constraint, same thing there's the center line, and there's the mate. You can go in here and delete these constraints, so that would make that something where you can now modify it. So I can get rid of that. You can edit. Let me back up, bring that one back. So mate 8 was the surface to surface. So if I wanted to modify my constraint, I could put a dimension in there. Let's just put 1 inch, throw it way up there. So there's 1 inch. So I can change the offset of that. So it's just a lot of flexibility in moving these parts. And this is one of those things that just takes a lot of practice and getting familiar with it and running into problems. It's hard to do perfect the first time. I expect that you're going to have a little bit of difficulty getting these all correct right out the bat. So it's going to take some trial and error and just getting familiar with this whole process and getting everything lined up. So just the key to it is think about how this part is going to look, how it's going to be assembled at the very end, and how these pieces all connect. If you can think about, you know, the bolts are always going to share the same centers. When you screw that cap screw down, it's going to stop when it gets to that that one surface on the counter bore. Those are all things that you have to keep in mind. So think about assembly and how it's going to look when it's going together, and that's going to help you out in the long run.